In this section we're going to look at the algebra of functions, and given two functions we can define or construct a number of new functions in a variety of ways. We can add the functions, we could subtract them, we could multiply them, and we could divide them. So the mechanics of all of these constructions are given below. For each of these constructions we specify a domain for the new function. If f of x and g of x are functions with domains, the domain f and the domain of g respectively, then f plus g of x is a new function, and the formula for it is given by the sum of the formulas for f and g for any given value of x. And its domain is the domain of f intersected with the domain of g. And it's not difficult to see that this function is a function. For any given x, f of x gives us a unique number, and g of x also gives us a unique number, and the formula f of x plus g of x gives us a unique y value for every x value we put into this machine. So that's our defining property of a function, and therefore this is a function. And in order for us to calculate f of x plus g of x, we have to be able to calculate both f of x and g of x, so the domain is the intersection of the domains of f and g. We have a similar story for f minus g of x. That's also a function. Its formula is given by f of x minus g of x, and again its domain is the intersection of the domains, because you have to be able to calculate both f and g in order to calculate this. F times g of x is the product of the values f of x and g of x, and again its domain is the intersection of the domains. And the quotient is slightly different. It's the quotient of the values, as you might expect, f over g of x. Its formula is given by f of x over g of x, and its domain is all of x in the intersection, and we must also leave out the ones where g of x equals 0, because we're not allowed to calculate when the denominator is 0. Now, sometimes you'll have cancellation here, but nevertheless this is implicit in the definition of f over g as a function, that you're not allowed to calculate this, or you're not allowed talk about f over g of x when g of x equals 0. Okay, let's look at a few examples. Suppose f of x is 1 over x minus 3, and g of x is the square root of x. And we're going to find formulas for all of these functions and their domains. So let's start with looking at the domain of f, and that's the set of all x such that x is not equal to 3, such that this denominator is not 3. And that's everything from minus infinity to 3, along with everything from 3 to infinity. And the domain of g is the set of all x so that x is greater than or equal to 0, because it's the square root function, and that's everything from 0 to infinity. Okay, let's look at our functions separately here. We'll work on parts A and B together here. Let's look at the function f plus g of x. We need a formula for that, and according to the definition, that's just the sum of the formulas. That's 1 over x minus 3 plus the square root of x. And its domain is the domain of f intersected with the domain of g. And that's the intersection of these two sets. It's every x value which is not equal to 3 intersected with all x values that are greater than or equal to 0. So both of these conditions must be met. So it's everything from 0 to 3, not including 3, along with everything from 3 to infinity. Now let's evaluate f plus g of 2. Well, we just work with the formula. It's f of 2, which is 1 over 2 minus 3, plus the square root of 2. And that's equal to minus 1 plus the square root of 2, or the square root of 2 minus 1. What about f minus g of x? What's its formula? Well, it's going to be f of x minus g of x. And again, its domain is going to be the intersection of the domains, so it's what we had before. And f minus g of 2 is now just f of 2, 1 over 2 minus 3 minus the square root of 2, minus g of 2, and that's equal to minus 1 minus the square root of 2. F times g of x, sometimes we put a little dot, a solid dot there to indicate f times g. That's the product of these two functions. So its formula is given by f of x times g of x, and we can tidy that up a little. It's the square root of x over x minus 3. The domain is again the intersection of the domains, so that's what we had before. And now when I evaluate at 2, I get 1 over 2 minus 3 times the square root of 2. That's minus the square root of 2. And lastly, a slightly tricky one, f over g of x is again just f of x over g of x, so it's 1 over x minus 3 divided by the square root of x, and that's equal to 1 over the square root of x times x minus 3. Now its domain is the intersection of the domains 0, 3, union 3 to infinity, and it's also less any points where g equals 0. So it's less the x values where the square root of x equals 0. So there's exactly one such x value. We have to omit those x values where the square root of x equals 0, and in particular that only happens when x equals 0. So this is this set without the point 0 here. So the domain here is equal to the domain of f over g is equal to everything from 0 to 3, not including 3, union everything from 3 to infinity. So it's slightly different than the previous ones. And now f over g of 2 is pretty easy to calculate. It's just this formula applied to 2. So it's 1 over the square root of 2 times 2 minus 3, so it's minus 1 over the square root of 2.